A scientific experiment often faces unexpected results. We are facing a real-life scientific mystery where a seemingly easy experiment did not work well. The experimenters already tested 2 ideas, but those ideas turned out to be incorrect. In today's episode, we will see their 3rd idea, how they came up with the idea, what the idea was, and whether the idea was correct. We will see how negative controls became the key to identifying the source of the problem. Through these episodes, I hope you will learn that negative controls can become a hero because they can help pinpoint the problem in life science experiments. Welcome to the thrilling world of negative controls. Hi everyone, welcome to the Foundational Skills in Life Sciences podcast. I'm your host, Dr. Synaptologica. We discuss the skills that life science scholars learn, use, and improve throughout professional activities. Your benefit is expressed in my motto, learn the skills, enjoy academic life. Last episodes. We are in a long mini-series of reading a life science paper. Today, we are in episode 22. If you are a new listener of my episodes, please start listening from episode 7. It was the start of the mini-series on reading. Starting in episode 18, we are discussing the details of negative controls of an experiment. These discussions were triggered when we discussed the category access labels of bar graphs in episode 16. In that episode, we talked about negative controls in our milestone article 1. It is the paper written by the laureates of the Nobel Prize in Physiology or Medicine 2023. We are now exploring a real story. It is a story about one specific pilot experiment that did not work well at first. The experiment is not specifically related to our milestone article 1, but we are discussing the story because I think it is a good opportunity to talk about a viewpoint that beginning scientists might not be aware of. The story will tell us that negative controls are important when we design life science experiments. It will also tell us that negative controls are important when we detect potential problems in life science experiments and when we troubleshoot them, always together with the positive controls. In episode 19, we talked about the experiment in its original problematic format. We have set the stage for understanding the problem. The problem was that the results of functional measurements were similar for the positive control that received an active chemical compound and the negative control that received an inactive compound. Because the functional measurements were similar for the positive and negative controls, the natural conclusion was that the active compound in the positive control was ineffective in stimulating a cell function. This was puzzling because other research groups had already reported that the active compound would stimulate this specific cell function that the experimenters were looking at. In episode 20, we talked about basically 2 things that the experimenters did. First, they read the literature extensively, and they realized that the cell function in both of their positive and negative controls was higher than the function under the resting conditions in the other researchers' hands. The experimenters were not sure how this happened, but they thought that the increased function in positive and negative controls could be related to the strange result that both controls were indistinguishable. So their troubleshooting strategy became a new search for an unknown process in the protocol that could have increased the cell function somehow before the chemical compounds were applied to the cells. The second thing that the experimenters did was based on this strategy. The experimenters tested 2 ideas for troubleshooting the problematic experiment. Idea 1 was that the cell function could have been wrongly increased during the chemical treatment period when any chemical compound was added to the cells, irrespective of whether the compound was active, inactive, or irrelevant. Here's a quick comment. What do we mean by irrelevant? An irrelevant chemical can be, for example, just water. Adding a chemical compound to the culture medium usually indicates adding a chemical compound in solution to the culture medium and mixing the culture medium well so that the added chemical compound would be diluted and distributed evenly in the medium. In some type of cultured cells, some functions are impacted by the simple action of mixing the solution. The turbulent flow of solutions near the cells could mechanically stimulate the cells. To test the idea 1, they designed the first troubleshooting experiment. It included no treatment negative control 1, in which no compound was added during the treatment period. And the result was that this negative control also reported the increased cell function. So the idea 1 turned out to be incorrect. The experimenters learned that the cause of the problem was not in treating the cells with any chemical compound. The second idea that the experimenters tested, that is, the idea 2, was that simply waiting for a long 1 hour during the treatment period could have increased the cell function even without adding any chemical compound. To test idea 2, they designed the second troubleshooting experiment. It included no treatment negative control 2, in which the cell function was measured immediately after a stabilization period that preceded the treatment period, and without applying any chemical compound. And the result was that this negative control also reported the increased cell function. So the idea 2 turned out to be incorrect. The experimenters learned that the cause of the problem was not in the treatment period itself. As a brief summary, both ideas 1 and 2 turned out to be incorrect. Both these ideas tested whether the cause of the problem was in the treatment period. Now that the experimenters learned that the treatment period was not the culprit, they moved their focus from the treatment period to the stabilization period, which was one procedure before in the experimental protocol. Today's episode. In today's episode, episode 22, we will keep talking about the troubleshooting efforts. Specifically, we will talk about the third troubleshooting experiment based on a further idea, idea 3. Design of the third troubleshooting experiment. After the second troubleshooting experiment, the experimenters thought this way. It is possible that the cell function could have changed even before the treatment period, that is, during the stabilization period. This is the period when the cells were simply placed in a fresh culture medium for 1 hour. Let's call it the idea 3 because it serves for the third troubleshooting experiment. To test this idea 3, they designed another negative control. In this negative control, they eliminated the stabilization period and the treatment period. So instead of waiting for 1 hour in the fresh medium during the stabilization period and for another 1 hour of chemical treatment, they measured the cell function immediately after the culture period while the cells were still bathed in the old culture medium. We can call it a no treatment negative control 3. The third troubleshooting experiment included 3 groups. The first 2 groups were the same as in the original experiment. 1. The positive control with the stabilization period and treated with an active compound during the treatment period. 2. The mock treatment negative control with the stabilization period and treated with an inactive compound during the treatment period. And 3. The no treatment negative control 3 measured immediately after the culture period, still in the old culture medium, and without stabilization period and without treatment period. Then they evaluated the cell function of the 3 groups. So, as in the first and the second troubleshooting experiments, there were 2 types of negative controls. If the idea 3 is correct, that is, if the cell function is increased by keeping the cells simply in a fresh medium for 1 hour during the stabilization period, then we can expect the following. The no treatment negative control 3, which does not have a stabilization period or a treatment period, will show a lower cell function than the positive control and the mock treatment negative control, which will go through the stabilization period and the treatment period. So the two types of negative controls will behave differently. Result of the third troubleshooting experiment. Then they did find a difference among the three groups for the first time in their hands. Whatever the result was, this was a huge improvement because it provided the first meaningful clue to understanding the mysterious situation. Here's the important thing. Because the experimenters found differences in the cell function among the groups, they could now tell which groups reported a high function level and which groups reported a low function level. Then what did they find specifically? Here's what they found. No treatment negative control 3 showed a lower cell function than the positive control or the mock treatment negative control. Let me say it again. No treatment negative control 3 showed a lower cell function than the positive control or the mock treatment negative control. So the idea 3 was correct. Now, what are your thoughts? I understand this situation might be a little confusing because we are using some special names of negative controls. Let's review the situation so that we are on the same page. The third troubleshooting experiment was designed to test the idea 3, which says that the cell function is increased by keeping the cells simply in a fresh medium for 1 hour during the stabilization period. Let's recall that before the stabilization period, the cells were in the culture period. On the day of the experiment, the old culture medium, which was bathing the cells, was replaced with a fresh medium, and the cells went into the 1 hour stabilization period. Here, we need 3 pieces of evidence to conclude solidly which experimental period was problematic. The first piece of evidence is that the cell function was low in the no treatment negative control 3. In this negative control, the function was measured immediately after the culture period, still in the old culture medium, and without the stabilization period or the treatment period. The second piece of evidence is that, in comparison to this low function group, the cell function turned out to be high both in the positive control and the mock treatment negative control. In these high function groups, the cells went through the culture period and then the stabilization period and the treatment period. The third piece of evidence is that there was no problem with the treatment period. This was shown in the previous first and second troubleshooting experiments. So the experimenters could conclude the following 2 things clearly. Before the stabilization period, the cell function was low. After the stabilization period, the cell function was increased. Based on this information, the culprit was determined to be the stabilization period. Somehow, the stabilization period seems to increase the cell function. In other words, something in the stabilization period stimulates the cells. How to proceed further? It is excellent that the experimenters could narrow down the problem to the stabilization period. We are now closer to seeing how the problem would be solved finally. But we are not there yet. What was wrong with the stabilization period? How you would proceed if you were a team member? This is it for today. In the next episode, we will talk about the final troubleshooting experiment. Your action. Until we meet next time, think about what could have gone wrong in the stabilization period. The period had been designed to stabilize or calm down the cells, but instead it stimulated the cells. How would you solve the problem? What are your further thoughts? When you get an idea, please send me an email about it. We can think about it together. My email address is ideas@synaptologica.com. Thank you for joining me in today's episode of Foundational Skills in Life Sciences. I'm Dr. Synaptologica. I'll see you soon. Bye for now.